we can't talk about all this without digging into the how
Yes.
this wasn't just a lucky glance through a telescope.
No.
This was all thanks to some seriously cutting-edge technology,
Quantum AI.
quantum AI. So for those of us who aren't quantum physicists, can you break down what exactly quantum AI is
Sure.
and why it was so crucial here?
Certainly, quantum AI at its core is a hybrid approach that blends the principles of quantum computing
Okay.
with the power of artificial intelligence algorithms.
Gotcha. So you know how traditional computers use bits, which are either a 0 or a 1?
Right.
Quantum computers use quantum bits or qubits,
Yes.
which can exist in multiple states simultaneously thanks to a phenomenon called superposition.
Right. It's like a coin spinning in the air before it lands.
Okay.
It's not heads or tails, but a combination of both until we look.
Right.
Qubits can be in multiple states like this,
Yeah.
simultaneously allowing much more complex calculations.
So instead of a simple yes or no, they can be kind of maybe or both at the same time.
Yeah, a good way to think about it.
That's wild.
It's like having 1,000 detectives looking for clues at the same time instead of just one.
So much faster.
Exactly. And when you're dealing with the immense and incredibly complex data sets coming from the James Webb Telescope,
Right.
which is observing Proxima b across multiple wavelengths and over extended periods,
Right.
this ability to test thousands of correlations at once becomes absolutely critical.
So that's why quantum AI is so important here.
It is Dr. John Preskill,
Eh.
a pioneer in quantum computing, put it well.
What did he say?
He said that quantum algorithms excel at identifying hidden correlations in complex data sets.
Makes sense.
Traditional computing might take months, even years,
Wow.
to detect subtle patterns that quantum-enhanced systems can find in days or even hours.
That's incredible. And the Webb telescope is certainly generating those massive data sets.
It's near-infrared spectrograph, or NISPEC. It's
Yeah.
essentially like a super-sensitive nose sniffing out the different gases present in Proxima b's atmosphere.
By analyzing the specific colors of light they absorb.
Exactly like a cosmic fingerprint reader.
I like that.
And then you have the mid-infrared instrument, or MIR,
Right, the heat camera.
precisely capable of detecting incredibly tiny temperature differences on the planet's surface from vast distances.
And we're talking about,
We're talking about sensitivities down to 1/10 of a degree Celsius.
wow.
But all this incredible data is raw and it's messy.
Right.
You've got interference from all sorts of cosmic sources, from dust to the overwhelming brightness of Proxima Centauri itself.
Yeah, that makes sense.
Filtering all that out is a massive computational challenge.
And that's where the limitations of previous observations came in, right?
Exactly.
Even Hubble couldn't quite give us this kind of detail.
It just didn't have the same capabilities.
So what did this quantum AI system do differently?
Well, it didn't just look at each piece of data in isolation.
Right.
It created a comprehensive, multidimensional model,
Okay.
incorporating all the different wavelengths, the time variations, and the spatial information all at once.
Wow.
This holistic approach allowed it to spot those subtle correlations that traditional methods simply missed.
Can you give us a concrete example of how this made a difference?
Of course.
Especially with those initial methane readings.
Sure, when traditional analysis looks for methane, it typically searches for specific absorption features at certain wavelengths of light.
Yeah.
The quantum AI system took a much broader view.
Gotcha.
It examined how those same absorption features changed over time,
Right.
and how those changes correlated with fluctuations in dozens of other atmospheric components.
Okay.
It was by seeing these interconnected patterns, these subtle dances between different molecules over time,
Yeah.
that the cyclical nature of the methane concentration potentially linked to those seasons was revealed.
So the patterns were likely always there in the web data.
They were.
But without the advanced processing power of quantum
I
AI,
just couldn't see them.
they were undetectable.
Precisely.
That's incredible. So we had the data all along, but we needed a whole new way of looking at it to unlock these secrets. And for someone following the search for life beyond Earth, this quantum AI breakthrough could potentially unlock a treasure trove of information hidden in existing telescope data.
You're absolutely right. It's like having a brand new set of eyes.
So what does the future hold now that we have this quantum key?
Well, the discoveries we've discussed have fundamentally reshaped our understanding of Proxima b,
Yeah.
revealing it as a far more dynamic and potentially hospitable world than we ever imagined.
And I hear NASA's already planning to spend a lot more time looking at Proxima b.
Oh yeah, they've already announced an extended observation campaign dedicating an additional 200 hours of Webb telescope time to Proxima b over the next 6 months.
200 more hours?
200 hours.
That's amazing.
This will give the quantum AI even more detailed data to analyze, potentially revealing even finer details about the planet's surface and atmosphere.
So what kinds of things will scientists be looking for in that new data?
Well, they'll be looking for more clues about the nature of those thermal oases,
Okay.
trying to determine whether they're caused by geological activity, thermal inertia, or maybe even liquid water.
Right.
They'll also be studying the magnetic field in more detail
Oh,
to see how effective it is at shielding the atmosphere from those powerful stellar flares.
that makes sense. And it's not just about more data, right?
Right.
NASA is also actively developing next generation quantum AI systems specifically tailored for analyzing exoplanet data.
They expect these enhanced systems to be up and running by early next year.
So even more powerful tools to uncover those hidden patterns.
Exactly, which promises even deeper insights, not just for Proxima b, but for thousands of other exoplanets already in Webb's observation queue.
Wow, so this could open the floodgates to a whole new era of exoplanet discovery.
I think it will. Dr. Jesse Christensen at NASA's Exoplanet Science Institute summed up the general feeling of cautious optimism.
What does she say?
She said that while we're not claiming to have found life on Proxima b,
Right.
we've certainly discovered a planet with far more favorable conditions than our previous models predicted.
Right, and this is forcing us to rethink what makes a planet habitable.
It is, especially around those abundant red dwarf stars.
Absolutely, and the implications are much broader than just Proxima b.
Well, much broader.
The success of quantum AI in pulling these hidden patterns out of Webb's data
Yes.
suggests that we should probably go back and re-examine existing data sets from other exoplanets.
I think so too.
Worlds we might have previously dismissed as uninteresting
Right.
could be harboring similar secrets, just waiting for the quantum AI to uncover them.
It's a very exciting time to be studying exoplanets.
It really is. It feels like just the beginning of what quantum computing can reveal about the universe.
The possibilities are endless.
This deep dive into Proxima b, powered by the incredible capabilities of quantum AI, has been nothing short of transformative.
I agree.
We've gone from a basic understanding of our nearest potentially habitable neighbor
Yes.
to a world with fluctuating methane,
Right.
unexpected seasons,
Huh.
mysterious thermal oases,
Yeah.
and a protective magnetic field, a far cry from the barren world many initially envisioned.
It's amazing what a difference a little quantum AI can make.
It really is, and it leaves us with a profound question to ponder. Considering these surprising findings, the dynamic atmosphere, the potential for liquid water in those warm zones, and the shield against stellar fury, what possibilities for life, perhaps in forms we can scarcely imagine,
Right.
might exist on worlds we once considered desolate?